Okay, here we've got a description of an experiment that you've probably seen a version of yourself. Okay, we've got light from a laser being transmitted through double slits. The separation is 0.5 millimeters. We've got a screen 10 meters away, and we've got the distance apart of the fringes. So we need to find the wavelength, first of all, of the light. Once we've done that, then we're probably in a position to find the other things. So the formula we're going to be using, we want to find the wavelength. So that's the value of lambda. And in your data booklet, we've got the formula lambda equals AX over D. And so we need an A, and we need an X, and we need a D. And A means if these are the slits, the separation between the slits. Oh, and we know what that is. That's 0.5 millimeters. So that's 0.5 millimeters is times 10 to the minus 3 meters. And then X is on the screen, the separation from the one point of maximum intensity to the next, okay, between the fringes, and that distance X is this 1.4 centimeters, so that's going to be 1.4 times centimeters, so that's 10 to the power minus 2 meters. And then we've got the distance D, which is 10 meters, so D is 10. And so therefore, all I need to do is to find lambda. I'm just going to plug my values into the formula. So lambda equals 0.5 times 10 to the power minus 3 times 1.4 times 10 to the power minus 2 all over 10. Okay, and I can put that into my calculator. The half of 1.4 is 0.7, and so if I work out the powers of 10, I'm going to have 7 times 10 to the power of minus 7 meters. Okay, and we've got to find, we found the wavelength, we've got to get the frequency, and we've got to state the colour. Well, actually working directly from the wavelength, if we convert this into nanometers, a nanometer, remember, is 10 to the power minus 9, so this is 700 nanometers, and you're supposed to have learned typical wavelengths for various forms of electromagnetic radiation. What we are here is at the absolute extreme long wavelength for visible light, so this must therefore be red light, so there's the colour. Okay, now to get the frequency, okay, we've got the wavelength. How do wavelength and frequency relate? Well, there's another formula in your data booklet, which is that V equals F lambda, okay, and the things in that formula, lambda is the wavelength which we've got, frequency is F, which is what we're trying to find, and this V is the speed of travel of electromagnetic radiation, otherwise known as C. So V equals C, which is 3.00 times 10 to the 8, and that's in meters seconds to the minus 1. Okay, so if I plug that into the formula, along with the value of lambda that I've got, I get 3.00 times 10 to the power of minus 8 equals F times, and then my lambda is my 7 times 10 to the minus 7 meters. Okay, section that off. If I want to find F, I'm going down here. So to find F, I have to do 3.00, not 10 to the minus 8, what am I talking about? 10 to the 8. 3.00 times 10 to the 8 is my V divided by 7.0, or to 7 times 10 to the minus 7. Okay, and I'm going to get, okay, I think I will have to use a calculator for 3 divided by 7, will I? I'll do it. So I'm doing, I don't know if you can see this, yes you can, 3 times 10 to the 8 over 7 times 10 to the minus 7, it's a bit, so it's 4.285, I'm going to round this to 4.3 times 10 to the power of 14, that's what the calculator is telling me there. Okay, I think that's probably a sensible level of precision given what looks like the precision in both units there. Okay, maybe I'm not too sure about that 0.3. What's that in? That's going to be in hertz. Okay, and I'm done.